So in this problem, you have a construction worker accidentally drops a brick from a high scaffold. So the word drops here implies that the initial velocity of the brick is 0 meters per second. What is the velocity? So it's asking us what is the final velocity of the brick after 4 seconds. So this right here tells you the time then. So it's 4 seconds. So I'll go ahead and write all my givens. The first given is that time is going to be 4 seconds. I'm also given that the initial velocity is 0 meters per second. So there's a third unknown given that's not stated in the problem. When an object's in free fall, as in this case with the brick falling from the scaffold, the only force that acts upon it is gravity. So that means that it experienced an acceleration in the negative direction of 9.8 meters per second squared then. And then your unknown is final velocity then. So now we're going to select the kinematic equation we need to solve this problem. So first I'm going to look for an equation with time in it. So this equation has time, this equation has time, this equation has time, and this equation lacks time. So I'll go ahead and eliminate that one. Next I'm looking for initial velocity. So this equation, this equation, this equation all have an initial velocity. Next I want to see which equation has acceleration then. This equation does not have acceleration, so I'll eliminate that one. This equation has acceleration, and this equation has acceleration. Then finally, I need the equation with final velocity then. This equation has final velocity here. This equation does not have final velocity, so I'm going to be using the second equation right here then. Let me go ahead and rewrite the equation from the previous slide. Final velocity is equal to initial velocity plus acceleration times time. And since final velocity is already isolated already, I don't need to do any rearranging because it's already by itself already. So I could go ahead and move on to the next part. So now I could calculate for my final velocity. So I'm going to write my equation. Final velocity is equal to initial velocity plus acceleration times time. So let me go ahead and plug in my values. The initial velocity was 0, and the acceleration for the object that's falling is negative 9.8 meters per second square, and the time that we're given was 4 seconds then. So 0 plus negative 9.8, that turns out to be a negative 39.2. Now because I'm dealing with velocity, my units for velocity is meters per second. So my answer then should be negative 39.2 meters per second. To double check if my answer is correct, I have to look at first my sign. So I have a negative value here, and it does make sense because the object is falling. So my answer should be negative then. Next thing I want to check is the magnitude of the value. So the next part I want to check out is the magnitude. So I got 39.2. Now this number does seem reasonable. It's not too small like 0.1. It's not too big like 1,000 or so. So our number does seem reasonable then. And finally, I have to check the unit. Since I'm dealing with velocity, the unit velocity is always going to be meters per second. So it looks like all three check out then. So moving on to part B, we're going to go ahead and find our givens, which are pretty much the same as part A. So we have a construction worker who accidentally drops a brick. And remember, when it says drops, it means that the initial velocity of the brick is meters per second. And we're going to still use the same given from part A. What is the velocity of the brick after 4 seconds? So we're still given the time is 4 seconds. But now in part B, it's asking us how far does the brick fall during this time? So when it's asking us how far, it's asking us for the y displacement then. So going to my givens, I'm given the initial velocity is 0 meters per second. I'm given the time is 4 seconds. Because the object is in free fall and the only force that acts upon an object in free fall is gravity, that means that experience an acceleration of negative 9.8 meters per second square. And our unknown is y displacement. So for the next part, we're going to have to figure out which kinematic equation we're going to use then. So first, I need a kinematic equation with the initial velocity. And all 4 kinematic equations have initial velocity, so that doesn't really help out in eliminating which equation to use. Next variable is time. So I need an equation with time in it. So this equation is good, it has time. This equation has time. This equation has time. This equation doesn't have time, so I'll go ahead and eliminate that. And the next one, acceleration. So this equation does not have acceleration, so I'll eliminate that one. Acceleration is here, and acceleration is here. And finally, I need an equation with the y displacement. So the second equation doesn't have it, so I'll eliminate that one. And so that leaves me the third equation then. And this is the equation I'll use to solve for my y displacement. Next, I'll go ahead and rewrite my equation. So I have the y displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared. Now luckily for us, the y displacement is already isolated already, so I don't need to rearrange the equation. I'm actually ready to go to the next step then. So now I'm going to use my equation. Y displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared. So I'll go ahead and plug in my values then. So fortunately, the initial velocity is 0, so that this whole term just becomes 0 plus 1/2 times acceleration, which is negative 9.8, times time squared, or in this case, it's times 4 squared. So I'll go ahead and rewrite this again. So I get 1/2 times negative 9.8 times 4 squared. If I multiply all out and square the 4, I should get a negative 78.4 meters. Finally, at the last step, I want to just double check my answer to make sure it's correct. So I found out from the previous slide that my answer is negative 78.4 meters. So first thing I want to check out, the units. In this case, I do have the correct units. Whenever you're dealing with displacement, the unit is meters. Next, I want to check the sign, positive or negative. In this case, because the object is falling downward, and we're taking the origin is where the object is initially at, so that means as the object falls, it's going to have negative displacement then. So it should be negative. And finally, the third point, we want to check to see if the magnitude of our value makes sense. So in our case, since it's falling for 4 seconds, it shouldn't be a small number like 1 meter, and shouldn't be a large number like 1,000 meters. So in our case, it's kind of reasonable. It's between 1 and 100. So in our case, our value does seem reasonable, so our answer checks out then.